sublimation goes up to a new level. Just going from a solid to a gas just instantly accelerates. So the water transfers that heat so quickly that the dry ice just literally almost explodes. Kind of thing you never want to close up, because the gas production is so fast, it's going to blow apart whatever you have put it in. So that's kind of cool. Sort of normal, sort of what we expect. But what people don't know about carbon dioxide, which is something we drink in our soda every day, is that it's not neutral, is it? Anyone know? Carbon dioxide, if it's not neutral, what is it? It's very acidic, which is why soda is like putting acid right in your teeth. So we can detect that if we have an indicator. So this is a green indicator. It's a universal indicator. And what it does is it changes color if there is an acid inside. Oh. That's why we have a tablecloth. A little bit more in here. So purple is base and red is acid.
Ooh.
Check it out.
That's
How cool is
cool.
that? I don't know if it'll make it to red. It might not make it to red. It's not a strong acid. But you guys have probably seen this before. I sense that people are like, ah. Buy this in QSC. So I brought something else that I wanted to show you. This is one I've been nervous about all week. Our laboratory technician made this many times this week, and every time he made it, it was so unstable that it reacted. And finally we got to today. I brought it down in the cart, and every bump I was just nervous. I talked Dan into it, and he had no idea. He was just like talking, and I was like, I'm not going to tell him about it. It's not that dangerous. Now, what it is, it's this liquid. This is sodium acetate. Believe it or not, this is just what you get if you take baking soda and vinegar and react them together. Concentrate that to a million times, and you get a powder. Take that powder, heat it up, add a little bit of water, and it will dissolve. Believe it or not, there is an incredible amount of solid inside this liquid. It should only be that dissolved at high temperature, but we've cooled this down. Is there a volunteer who want to feel the bottom of this? Is it warm, cold?
It's cold, room temperature.
Room temperature? Okay. So I'm not tricking you guys, right? This is definitely room temperature. What we're going to do is take this supersaturated solution, a solution that holds more solid than it should, and we're going to try to nucleate crystallization. And we're going to see exactly how much solid is in here. And I've been actually nervous about this for a couple of days because it's so unstable. It kept on freezing before. It kept on not freezing, but precipitating earlier. So I'm going to take off this lid. And I just want you to watch, because every once in a while when you do this, the lid drops a tiny piece of dust in there. Turns out you need this little bit of dust, or this little surface, in order to cause the crystals to come out. So let's see. We can do this. All right, so far so good. What we want to do next is take one of the original crystals. This is the powder. This is how we made it. By the way, Google this, hot ice. You can see this yourself. People can buy this. You can do this in your kitchen. You didn't hear that from me. But, you can buy this stuff. It's food grade sodium acetate. So what we're going to do is take a couple of crystals. You can probably see them in the front row here. And I'm actually going to try to, I think there's a couple of crystals on here if you look carefully, but I'm going to wipe them off. And we're going to see if a microscopic crystal could actually cause this thing to suddenly crystallize. Oh, thanks. So I don't know if it will. This may not work. So let's see if it does. You guys see this in the front row?
Oh. Yeah, it is.
Oh, look at that.
Whoa.
You guys can see this. See those crystals forming? So hopefully this flask is big enough. It feels like it's going to keep going, doesn't it?
Yeah.
Okay, you see them creeping up the sides? That's where there was liquid on the side. It's really grabbing every last crystal. It's kind of an amazing crystallization, isn't it?
What's the temperature?
Oh, it's not too bad. It's a little bit warm. A little bit in there. But look at how much solid was packed inside there. Pretty amazing, right? We did this in lab a couple days ago. It wasn't this fast, it was a different chemical, but this is chemistry, this is science. If you're interested in stuff like this, boy, there are demos in biology that are just as awesome, and physics. So thanks guys for this attention. I have one more thing to show you. Are there any questions about this? Yeah.
How do you take it out?
Yeah, narrow neck, big bottom, kind of hard. What you do is you heat it up again, and then it melts, and you pour it out.
Oh.
Yeah, it doesn't melt actually, it redissolves, and then you pour it out. Great question. Yeah. Well, this is basically sort of like crystallized vinegar with a little bit of sodium added to it. So it would be very tangy. It's got a bit of it's actually a little bit basic. So it's not good to eat. It's not going to taste good. It's only slightly toxic, believe it or not. As dramatic as it looks by ingestion. Oh, I think it would be okay. Actually, if you take this and you kind of probe around in it, it's sort of mushy. It doesn't make like these really hard crystals. So that's one thing we can't see here. What if you eat it? That's a great question.
Question you should always ask in science.
I want to show you, and this is a trick that chemists love to do. This is the RST Academy. Welcome to the RST Academy. I just wanted to say you're all very, very important to us as faculty and staff here. We really want you to succeed and transfer and go follow those dreams in these difficult but really important fields. So, I prepared a sign for everyone who's here.